Okay. I think we're live via Zoom.
Test, test. I think that's right. Okay. If this is on properly, good morning. Welcome to the second week of live circuits, the morning demo. Yeah, so last week we built an Atari Punk console. That was pretty cool. I don't have it right in front of me, but well, why don't I grab it? Because I'm pretty proud of that. That build ended up happening. That build ended up happening a lot faster than I thought it would. So today I thought, why don't we just have a little bit more of a, open plan for this kind of thing. But here's the Atari Punk console. It's super cute, just on its little breadboard. Obviously missing power and everything. Sounds cool. You know what sounds even cooler? This right here is a Texas Instruments Speak and Read. So you've probably heard of a Speak and Spell. Well, this is essentially the same thing with just some modified functions. Let me flip that over for you and show you what that looks like. Probably should have started with this side, but that's okay. I'm gonna make sure the circuit board doesn't fall out. So that's what that looks like. Let me turn off this little light. All right, there we go. You probably won't be able to hear this, but you know what? Of course you won't, because there are no batteries in it, which is actually how I like it. Because I don't want to send any power anywhere it shouldn't be while I'm circuit bending this. So that's what we're doing today. We are going to be doing a little circuit bending. We're going to go into this cool circuit board, touch some points to other points that probably shouldn't be touched, and see what happens. Last week, I also showed off a circuit bent dinosaur synth of mine, which is pretty cool. But I'm not going to do that this week because I just want to show you this. So first, let's go over some materials. Obviously, the subject on the dissecting table. Got some D-cell batteries that we're going to need to use. Again, I don't keep these in there while I'm messing around with stuff. Well, I'm like soldering wires particularly because I don't want to route any of the power anywhere it shouldn't be, especially while I'm soldering. That said, we're not in a lot of danger about breaking this thing. 1.5 times 4, so 6 volts. 6 volts can't really do too much damage, something like this. But knock on fake wood. So what else? We got a little breadboard to the side. This I'm just going to use to hold my potentiometers while I'm making some connections. Otherwise, you have to use 2 hands for it. And the biggest thing I found with circuit bending is just I need more hands to do this, especially, you're going to see this later, but in order to actually have this be playing audio so that you can test if it's working, you have to be pressing buttons the entire time. So you have to be holding it while kind of using the other hand, using one hand to make connections, the other hand to press, not random, they have to be specific buttons for it in order to work. So that's incredibly annoying. But at least you are here to share that struggle with me. That's better. Next, got a soldering iron. This is a TS80, sorry. It is a portable soldering iron, USB-C powered, pretty cheap, really great for the price. And it's portable. Maybe one day I'll upgrade, but for now, this is good. I got this tiny little tip on it. Usually use a chisel tip, but as you can see, there are a lot of tiny points right here that I don't want to be accidentally shorting while I'm connecting wires. Next, this is just some wet cloth for wiping solder off the soldering iron. Normally I prefer, I don't know if it's, yeah, brass. It's like a brass sponge kind of thing. It's like, it's like steel wool, but it's brass. That's usually the preferred way to wipe off solder. I don't have that on me right now, so wet cloth is going to have to do. That's just a t-shirt that I rip every single time I need a little piece of cloth. Then, of course, we got our soldering iron. This is my favorite kind of solder. It's perfect thickness, 6040 rosin core. Love it. Just excellent, excellent soldering iron. I will never use anything else unless I have to have a thinner gauge, which honestly I may have to do, but I think it'll be fine. What else? Snippies. I always forget what these are called, but like they're very specific because they have this really nice angle, so you can get as close as possible to the board in terms of cutting leads. However, I don't think we'll be doing much of that today. I'll probably just be snipping wires. Then we got needle nose pliers, always handy. Then we got this like multi-tool looking thing. It's just it's like the cheapest wire stripper on Amazon when you search it up. I'm going to be using this for a little bit of crimping and just some wire stripping. That's the main thing. Though, as you can see, it's like pretty rusted. I don't know what's up with that. And lastly, I believe this is lastly, wire. So I've got a couple of different colors of wire, but it's like very little, but we don't need much. We've got some blue. I don't need to show it to you. You'll see. We got blue, yellow, black, green, white. What more do you need? And of course, because I am using leaded solder, I got some good ventilation going right now. I have my window open. It's a beautiful day, so that's fine. And I'm actually gonna open my door, be right back to make sure that, you know, we got a flow. Okay, cool. So, what do I want to do first? I guess the first thing, oh, and of course, the best tool of all, coffee. Got to get that. It's so early in the morning. And of course, I just spilled a tiny bit on my desk. Oh, but that's okay. There's nothing particularly important on here. My soldering iron. Okay, cool. So let's test out this new tip first, because this is honestly the first time I've used it. I haven't even used this iron in like what feels like a year. Okay, that's good. You can see the magic smoke. You can kind of see it's just chilling on the side there as opposed to evenly spreading. That's not a good sign. I think that means it's a little too hot. So I'm going to wipe it off. Okay, that's better. See that? Maybe you can't, but it's a lot better. Okay, so you probably can't see this, but I've already marked one point that I know is good for distortion. And so I'm just going to solder a wire to that. But of course, first thing I got to do is strip the wire. But why don't I talk a little bit about this product while I am doing that? So as I said, this is a speak and read. I think it's from the 90s, maybe the 80s. They are one of the most popular, the Speak and Blank series, Speak and Read, Speak and Math, Speak and Spell are some of the most popular circuit bending tools because, well, they used to be everywhere. Now they've kind of been all bought up, but they have speech synthesizer chips, which are absolutely amazing. This was before you could store just tons and tons of samples in a single microchip. So what they did is it was somehow easier for them to develop an entire microchip to, you know, learn English vowels and consonants and string them together and be able to say them on the fly. That said, though, it does have a pretty limited vocabulary. Sometimes you'll put in words and it just won't know what you're talking about, despite them not being very complicated words. So that's okay. You know, I'm just doing this because it sounds cool. Yeah, so because of the speech synthesizer chip, you can just really mess with it to create some crazy sounds. As you can see, there's just so many points to play with here. It's kind of a circuit bender's paradise. Yeah, and as you can see, I have some wires already on there. I don't even know if those work. Those were done a long time ago. And then I got kind of fed up with how slow everything was because of how difficult it is to kind of wrangle this thing while you're circuit bending it. But you know, now that I'm on camera, I have to do it. Also, I didn't really cover all the pieces we're going to use because this is really important. This is my case. It's a very ugly case full of hardware. So we got a lot of potentiometers, as you can see, some interesting switches, foot switches, some 1/4-inch jacks, some toggle switches, buttons, LEDs, and then some outputs. So those are going to come in very handy later. I also imagine I'll eventually want to put in a LFO into this thing, which will require a 555 chip. That's for another day. Okay, so I'm still stripping wire. Yeah, this is going to be a very chill live stream. So, you know, take a seat, sip your coffee, just watch me do this, or follow along with at home if you have the ability. Okay, so first thing we got to do before you hook up a wire is tin that wire, which just means, you know, spread some solder across the lead, which is going to make it able to, I don't know what the word is that I'm looking for, but it's going to make it a lot easier to hook up to other points. So that is not my solder, that is a wire. All right, making sure this is hot enough. Hold it to the wire for a few seconds, let it warm up. Apply some solder, and then you're going to watch it just spread evenly across the entire thing. Beautiful. As you can see, I'm using some little helping hands for this kind of thing. As I said earlier, circuit bending is a lot of just like, man, I wish I had another hand. So these helping hands are kind of lifesavers when it comes to that. Boom. I'm kind of debating if it's faster if I like tin all these wires ahead of time. But you know what, let's just play around that for now. Okay, so I want this wire to go right there. So, you know, I'm going to shorten this even more so there's just not a lot of leeway, because you don't want your wires to accidentally short to other points. And I believe these even rows are the different, you know, memory chips, speech synthesizer chips, that kind of thing. So we got to be careful, because if you overheat a leg, you know, that's not good. So actually, that said, I think the best way to do this is going to be first to add a little bit of solder. And then melt it. I think it's wires. And then come back with the wire, heat up the solder that's already on the point, and just attach it that way. Otherwise, I would need 3 hands to do this. Okay, trying to get a good angle. Great. Oh, and there you go. I did exactly what I was trying to avoid. I shorted this. Okay, so awesome lesson. Don't add too much solder or you will short that stuff. I'm gonna go grab my solder sucker. Be back in 1 second. All right. You know how I was talking about needing solder with a thinner gauge? I think this might be one of those cases, because these points are just so close together. These wires are also super annoying. Put that under there. Fantastic. So solder sucker does exactly what it sounds like. It's going to suck up any melted solder that you've accidentally place. So you gotta heat it up and boom. Gone. However, let's just make sure, like, crystal clear sure that they're not connected, because it'd be a shame to short out one of the most important chips on there. So another great skill, continuity testing. You get your multimeter, set it to continuity mode. Right now it's in diode mode. It's like it shares these two functions in the same little switch. Let me move this. Right here, that's what you're gonna look for. It's that little, looks like someone talking or something like that. That's because it's gonna make a sound. There's continuity. So for example, I don't know if you can hear that, but it's beeping quite loudly. Okay, looks like we are good. No beeping when you touch those 2 points, meaning there is no longer a solder bridge connecting those two. All right, so let me bust out the thinner core, the thinner gauge solder. This is 0.3. But again, same chemical makeup, 60-40. Does it say the gauge on here? This was, oh, this was 1 millimeter. This is 0.3 millimeters. So this is going to be tiny. This is actually perfect. So you can see I've never opened this before. Oh, that is thin. I've never used solder this thin, so this will be a learning experience for everyone. Okay. Some tape. Let me cut that. Okay, there's still some tape on there, but you know what? Good enough for now. Wow, this is really tiny. This actually might be too tiny, but we will see. All right, so let me rub off the last bit of that other solder and let's see how this spreads. Beautifully, okay. Boy, I sure am glad I'm not using the chisel tip right now. Okay, so let's add just a teensy bit of solder to this. Okay. Might be enough. We shall see. Boy, I hope I don't have to connect a wire right next to it too, because that's gonna suck. Let's add a little bit more solder on there, because normally I would be placing the wire first and then adding solder to connect the two. But because this is such a delicate operation, I don't want to risk it. All right, so I'm holding the tinned wire to this point, going to melt it so that they fuse. Gonna hold it there. Okay, we got our first connection, baby. Sweet. Got very dark in my room all of a sudden. All right. Honestly, thinner gauge wire is really going to be a lifesaver here, but for now, this works. Okay, I'm not going back. Already wasted enough time. Okay, so boom. Awesome. Got that wire. Now let's do what circuit bending is actually about. Let's start connecting some points. I'm going to switch to this webcam mic so that you're actually able to hear the sounds that are coming out. But first, I'm going to put on these batteries. I mean, I hope that you'll be able to hear them. I have no way of knowing. For some reason, putting in batteries, it's just never been good at it. It's pretty pathetic. Okay, boom, did that. So I'm going to do something a little interesting here. So on this breadboard, as I mentioned before, is where I have a potentiometer, which is obviously has some variable resistance to it. And I do that before, instead of just connecting these two wires directly, you know, that might have some adverse effects. So what I always do is I put it into a potentiometer first to kind of suss out how much resistance or how little resistance it'll take to, you know, actually turn this thing off. Because from my experience, like it's a very finicky machine. If it receives too much something rather, then it'll just shut off. So, and we don't want that. So I'm using a 100K resistor. And of course, this will, if it actually works, this will give us control over how it sounds. All right, so I'm going to switch the mic. Boom.
There we go. Test, test. Think you can hear me. I'm gonna take another sip of my coffee. Love that giant thing of Folgers. Okay, so first, why don't we do it with the bend, without the bend, just to see how it sounds normally. All right, so the on button is right here.
Word tap, level 1. Word tap, level 2.
So that already sounds pretty cool already. So I'm going to turn it off. It is off. Going to connect these bends. See what happens. I mean, it would be cool if I also had a switch in here. First, let's just see what this sounds like. Let's see if it turns on, honestly, with it connected. Ooh. That sounds so cool. You can see what I'm talking about in terms of like this being really annoying to have to wrangle. I'm gonna put this on this side. Just hope nothing gets shorted. Is it still making sounds? Okay, so it seems to have a pitch and a distortion effect, which is interesting. However, once you turn it to about 3/4 of the way, it stops making noise. So that's interesting. So I have some options. I could just leave this for later, or I could also bust out the multimeter and see exactly what resistance values work for this. Though honestly, I know there's another pitch bend in here, there must be. And I could just leave this as just a push button thing or a toggle switch thing to just have the distortion effect and then save pitch for another controller. I think that would be smart. So maybe I run it through a fixed resistor. I think that might be the move in this case. Let's see, how are we doing? Okay, I'm gonna check that resistance value because there's a very clear threshold. Ooh. Okay, so this is difficult because I have one side of it, it's a higher pitch, but it does this interesting distortion, like lengthening, like it adds some like, it's like what is it called? A bridge bucket delay is the only thing I can compare it to right now, where it's actually fake delay, or it's like fake reverb that is just delays stacked on top of each other. I don't know if that makes any sense. But now it's only making that sound. Ooh, okay. All right, that's where I want that. Okay. So I'm going to take out these batteries to disconnect it. I'm going to measure that value on the resistor, and I'm going to write it down for later. Don't feel like soldering the whole thing right now. Okay. Soldering iron is resting at 200 degrees Celsius. Love that. I'm going to switch back to my headset mic.
All right, I think that's doing it. Great. All right, we're on a roll again. Circuit bending is a very time-intensive process, but you know, it's fun. It's a very, very fun thing to do. Okay. Grabbing the multimeter again. Gonna turn it on and put it in resistance mode. I'm then going to unclip these alligator clips from the circuit board and instead attach them to my two leads that will tell me what's the resistance. I might also need to get a new multimeter. The continuity thing has been weird lately. Okay. Interesting. This is telling me it's at 1. It's like it's really shifting over here. Instead of just landing on a value. Oh, it's because I'm touching that. Oh, I really hope that wasn't the case earlier. Okay, but this is at 40K right now. I'm gonna try this again because the magnet on the speaker may have been messing with this. You see what I'm talking about? There's just so much stuff going on. It's such. If I didn't have this camera right here, I'd like actually have all my stuff spread out. But as you can see, the multimeter is still changing values, which I really don't like. Okay, but that's just like electromagnetic interference from this other stuff. 40K, I can remember that, right? Fantastic. Oh, I didn't want to unclip the multimeter. 40K. That off. Don't get that tangled. Just gonna see what this sounds like again at 40K, but not touching the speaker. Just gonna write down 40K and then I'll like actually label it later, considering like I only have the one bend point now. So, you know, what's the point? And I'll probably end up using like, because I don't even know if 40K resistors exist. 4.7K is a very common value. or I'm sorry, 47K is a very common value. And then I think the closest would be either 4.3 or 3.7. I forget. Though obviously you can get some uncommon values, but who's got time for that now? Okay. Putting batteries back in. Oh my God, see what I'm talking about? These batteries, the springs are just so strong in this thing. I never had problems with this before. Okay. Putting this wire over here so it doesn't accidentally touch anything. Or not. You know, just or not. Gonna switch the mic.
Mic is switched. Let's hear what it sounds like with it connected. Okay, that's actually the same. Awesome. So, and it also appears that anything over 40K, let me double check that that's over, not under, is going to just kind of stop it. So I have to make sure to choose a value under it, okay? Very valuable information. Oh, these wires. You know, I've said it before, I'll say it again. I live in prison of my own wires. Okay, white. There we go. Boom. Easy stuff. There you go. Get these away from all these nasty signals so we get a clean resistor, we get a clean reading. You can't even see this. However, it doesn't matter because it's like giving me super inconsistent readings right now. Okay, that's 86. Oh. So you know what? I was wrong. You're gonna actually want 40K or above. Anything below that is going to stop the audio. Awesome. Okay, I'm really glad that I checked that because now I know and I won't have to return to that later. I'm actually drilling holes and everything. So 40K or below white to black. And I could have that as a potentiometer with a resistor, with like a 40K resistor in series. No, wait, not above, not below, above. I could have a resistor in series with that potentiometer so that even when the potentiometer is at 0, we are at, let me switch this.
When the potentiometer is at 0, we're still at 40K, so we can never make that mistake. But I think the results aren't even that spectacular. Okay, but that's, I'm going to label this as distortion. Okay. Fantastic. Those are done. Now I have some images that I'm also consulting for potential bends. So let's look for another one. I'm seeing fast loop. I would love a loop. Interesting. And it's saying to check out these 2 points right here, right next to each other. That's annoying. To have to wire 2 wires right there so close to each other. Let's see how I want to do this. Well, I guess I'd be just shorting them. But then again, I'd have to control that short so that it would only short when I had a message. So that doesn't actually help me. Let's just see what happens when I touch them together. I'm gonna grab an alligator clip for this. I grab a new alligator clip. A yellow one, why not? Let me switch the microphone back so you can hear.
What it sounds like.
Word tap. Level 1. Word tap.
Ooh,
Word tap. Word.
I hope you guys can hear that.
Words. Words.
Okay, that is awesome. That is definitely a button or a momentary toggle switch right there. That is so cool. I'm so curious how that'll sound with a pitch bend too. So I'm gonna mark those with a pen so I know. But this is again going to be a challenge with wiring, but I think we are up to that challenge.
So what color do I want this to be? Why don't I make it to blue? I do have blue. Not very much, but you know what, let's just kill this. You know, assuming that it's solid core, I don't want to have to deal with any stranded core right now. So let's just strip a tiny bit of this. Let's see what's inside. Solid core, fantastic. For those at home who may be watching and don't know what stranded core is versus solid core, stranded core wire is made up of strands of metal inside, whereas, and then, so those will be kind of wrapped together. But then once you kind of take off the plastic insulator sheath, then they kind of come apart. You have to twist them back, tin them so that they all stick together. I mean, you have to tin these anyways, but I just don't want to deal with that. Also, you may notice that these wires that I'm creating are very long, and that's just because I don't know where all this hardware is going to eventually sit. So, and I don't want to have to resolder these wires again. So I'm just creating very long ones so that I can always cut down, but I can never cut up. Yeah, but as you can see, there's not that much space to add this hardware. You got the handle, you have these sides, and that's about it. And then you have like here, sort of, but you can't do anything in this giant part because that's where the capacitive touch sensor is. And if you drill through that, probably doesn't help. I don't know for sure. I've never done it. But, you know, I think that's, you know, I should show you guys what I'm doing. Though it's not very interesting. Yeah. So if you ever see one of these at a thrift store or something, I highly recommend picking it up to circuit bend yourself, to give it to your good friend Lucas to circuit bend for himself or for you. Happy to do it. Or honestly to resell on eBay. These goes for a lot of money ever since they kind of became circuit bending staples. Which is, as I said, kind of hinted at earlier, they've all been kind of bought up and are now like kind of collector's things, but you know, you can still get them for, I don't know, I haven't checked recently, but I think it's like 30 bucks, 30, 40. Every time I say it, it probably goes up $1. So I'm going to stop saying it. Okay. So let's get this out of the way for a second while we wire this stuff up. Not wire it up. While we tin it up. This is a very long wire. Boom. And you know, why don't I, yeah. No, I'm just gonna leave those. Okay. Oh, see, okay, see my soldering iron stopped. It went down because it was not in use. But like, how does it know it's not in use, you know? It honestly might have like an accelerometer that knows when it's being picked up or something. The coolest thing about this is it's like completely open source, as far as I know. It's really easy to access the insides and change the firmware. So like theoretically, you could program this to play Tetris. I think I've seen someone do that, though maybe that was a dream. I don't know. Okay, so boom, got the magic smoke again. Gonna solder that. And gonna tin that, boom. This is hot. Wipe that over there. Okay, one down. Yeah, but to go back to what I was saying, I found my speak and read at a thrift store in Los Angeles. It's probably the best toy I've ever picked up in a thrift store. Which is always, whenever I go into any thrift store, that's the very first section I go to is the electronics and the kids' toys. You know, kids' toys are obviously very cheap. And if you break them, it's not a huge deal. Just get another. Not a huge deal at all. Okay. Move that away. Here. So again, we have some very fine soldering ahead of us. So thin solder. I don't really know if it's like super bad to be mixing solders. No, it's fine because obviously this is a different kind of solder. For all I know, this is lead free, which I should probably be using, but you know, I just prefer lead solder because it's so shiny and lead free is not shiny. So why would you ever want to use that? It's because you don't want lead poisoning. That's why. All right, we gotta get a better angle on this. Or honestly, like a freaking microscope. I wonder if I had a chisel tip, I could hold it up against. I could put the chisel to its side, that kind of thing. Because while a very fine point like this, I mean, it's not even that fine, but like the finer the point, the more accurate you can get with your tip placement. But the less surface area, so the more difficult it is to heat up and spread solder. So that's a very important trade-off. Okay. That looks amazing, if I do say so myself. Yeah. So one thing I didn't know when I was first starting off to solder is that you're not actually using solder as, or you don't want to be using solder as the conductive material itself. You want to be using it more like glue. You want to use it to connect the conductive material. It is conductive, but it's like, you don't want that to be the conductor. So for example, if you have a wire going into a, I don't know, some kind of through hole component, you don't want it so that the solder is just covering both of them and then that makes the connection. You want the wire to actually be touching that board or component or whatever, and then you're gluing it in place, and that's going to give you much better results. So might not actually change how you do things, but it is an interesting, more correct way, I suppose, to think about it. Okay, so let's do this. I'm gonna put this on the right side, right there. Gonna melt it, and let's see what happens. Okay, this is too much solder. I might also have to dab my cloth in some more water because as I touch it, I'm kind of, it smells bad. It smells like burnt something. Burnt cloth, I suppose. Might need to apply a little bit more solder because it's not really melting the way I want it to. Oh. And there we go. Beautiful. I mean, it's not that beautiful, but it works. That's what matters. Okay, where to? Right next to each other. So annoying. The results are just too amazing. So again, gonna clip this lead so that I won't accidentally short other stuff. Gonna use my needle nose pliers to straighten that out a little bit. That looks properly tinned, even though, I mean, I don't even know how you would really distinguish that, but I guess it's more shiny. Okay, gonna some more solder to this. Hopefully I placed enough early on. Ooh, don't want to burn that. I'm gonna actually clip this just a tiny bit more. And that's gonna go somewhere in my room, and I'm gonna step on it later, and it's gonna hurt, but it's okay. Okay, let's see how that looks. You know, it feels secure, but it doesn't look secure. Ooh, no. Okay, there we go. That's, remelt it one more time. Let it set. Great. So that reaction was because it had started to touch this little, I should not point at this with my soldering iron. It had started to touch this little path. And if you could do that, it's going to short. Boy, that doesn't smell good. And you can see that this path is actually attached to these two little dudes, little pokey guys. Sorry, language is failing me. It is still early in the morning. Okay, so let's, I should have unplugged this too before this happened, but so what? Let us turn this back on and hear what this sounds like.
To see if I made any mistakes.
Where's app? Level 1.
All right, that's still making noise. Always a good sign.
Where's app? Level 2. Where's app? Left 3. Where's app? Level 3.
Now what's going on with this connection? I'm gonna put it in a breadboard. You know, for funsies, why don't I put it in an actual switch so we can play around with that? That's what you guys want, right? Okay. Little breadboard switch. Looks like this, goes straight into your breadboard. Never actually used one of these, but. Okay, gotta go there. Plug that in. So, put this on this side. See what that sounds like.
Where's app?
Ooh.
Where's app? Level 2. Where's app? Level 3. You win. Where's app? Where's app?
Okay, that's awesome. Glad that works. So based on that one little test, it seems that it will not understand inputs, like you pressing the buttons. It will not respond to those while it's in loop mode, which makes sense. It's probably withholding some information from, let me switch this microphone.
Withholding some information from this, whatever this giant chip is, and that's causing it to loop. So if you break that connection, it makes sense that it wouldn't register anything new because it is a loop. Okay, so, you know, I wonder. No, I don't wonder actually. I was gonna say what happens when you put a potentiometer in that, but that doesn't make a lot of sense. Maybe I'll do that later. So for right now, I'm just gonna do blue to blue. And I want a normally closed button. Or momentary switch. And that's going to be loop. Awesome. 2 bends in, and we're only an hour in. That's progress in my book. Okay, what's next? You know what's next is actually going to get more coffee. I'll be right back. You can look at this awesome thing in the meantime. Okay. And I'm back. Sorry about that. Okay. Let's see what we got. I'm looking at this image again to see some potential ideas. It's a lot of glitch stuff, pitch and voice distortion. That always is good. Okay, so you got an orange. So from what I can tell, it suggests connecting this second one here, which is it's very interesting because like that seems like a connection to the screen, the little LCD screen. Or it's connected to the front because like I can see a ribbon cable protruding from underneath it. So that's an interesting suggestion, but maybe that's just ground. Maybe that's just like for the random choice. And then the other connection is it actually might be this little black one. I think it is. So actually, that's a pitch we already discovered to some extent. So let's just hear what that sounds like. And that recommends using a 47K resistor. Hey, that sounds a lot like what we did earlier. So very similar effect, but let's see this version. So I'm gonna grab a 47K resistor from my handy dandy resistor kit. One day when I'm fabulously wealthy and well organized, I will have an actual way to organize these, but until then, this will have to do. It's not in that stack, it's in this stack, 10K, 22K, 47K, fantastic. So just gonna grab the one, use my clippy guy to do that. Hold on to him so he doesn't go flying. Sorry, I don't know why I'm gendering all these components as male. I think it's just because like they're all little dudes, you know, which I guess is gender neutral, but still. Okay. Got my 47K resistor hiding underneath this. Gonna put it right here. Gonna bend the legs with my needle nose pliers. Put that here. And you know, why don't I actually just use this switch as it's intended to be used? So we got that. Already got my black wire. Just a cup of coffee. I love coffee, you guys. So, boom. Gonna put this black wire. Let me move all this a little. Black wire to this 4.7K. Then I'm gonna grab another wire, put that in this the middle pin of the switch, and have that there. I'm gonna remove these for now just so it's less tangled. Put these blue wires underneath this and confirm that I want to be touching this guy. So I'm gonna put this here. Why don't I? And let's see what happens when I touch this to that when it's on.
Water tap, level 1. Water tap, level 2.
So I actually have to have the switch on.
So that
Water
I
tap,
can actually do this.
level 3. Water tap, level 1. Water tap, level 2. Water tap, level 3.
Okay, so let's compare that to what we had earlier.
Water tap, level 1. Water tap, level 2. Water tap, level 3.
Okay, I like ours more. It's definitely grittier. It's not as high pitched, even though we'll be able to
Adjust that later. But I'm glad I tried that. So I can unplug that. What's next? Now I'm seeing pitch up and down is on two separate pins, which is interesting because that's usually not the case. It's usually the case where you attach a pot to, well, what you normally do is you'd remove a resistor and replace it with a potentiometer, so that whereas the resistor used to set the pitch for everything, you now have the ability to control that resistance and vary it over time, I guess. But maybe this person, when kind of taking this photo, didn't want to kind of take apart the circuit board, which I completely understand. It's such a pain to kind of wrangle that I wouldn't want to flip it over, because in order to do that, you have to remove the speaker. Yeah. So we'll come back to that, because like pitch control is super important. Okay, I'm seeing pitch control with distortion needs 162K resistor. We can do that. That's doable. So let's do something. I'm gonna first, on my breadboard, wire up the appropriate amount of resistance. I'm gonna put a 162 in series with my 100K, and then connect those 2 points and see what happens. I'm just kind of debating if it's worth wiring it up already, but Well, first, why don't I mark it? Can't do any harm to do that. All right, so let's see. This first point is going to be 1, 2. Do this with a mouse. Normally I'd have these pictures printed out so I can actually draw on them, but I don't have a printer. So 1, 2, 3, 4, 5, 6, 7, 8 is the 8th on this top row here. 1, 2, 3, 4, 5, 6, 7, 8. Mark that with my little marker. Okay. I don't know if it's just I think my circuit board is just a different revision than the one I'm looking to, even though there shouldn't be that many changes. So like some of the placement is just a little bit off. But that should be right. God, I hope it is. Maybe. Definitely 8. And then let's, you know what, let's just do it for testing purposes. I won't actually start wiring things. I'll just touch the wires and see what happens. So we got 1, 2, 3. Digitally. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 from the right. 9 to the right, rather. So we got this top. You go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we got those 2 marked. So that's 3 pins away. 1, 2, 3. Okay, that one's definitely right. And I'm just comparing the circuit boards not by pin but by their actual their paths. So I'm like, oh, this pin is connected to this path. This other pin is 4 pins away in relation. So at least you can count on those because those connections are all going to be the same. It's just placement that switches with revisions typically. So I'm going to hook up a resistor to 2 wires, touch to the wires, see what happens. So let's bust out a 162. I don't even know if I have 162. No. I have 100K and 220K and nothing in the middle. So we're gonna have to do a little math here. How do we get 160K through addition? So I could do 100K plus 47K, which will give me 147. It says needs resistor 162K, but like, does it really need it? It's always better to err on this cautious side. So you know what, let's just go straight for 220K. If it's too much, it just means that the pitch will be deeper if if this is like other things that I've circuit bent. So I got 10K, 22K, 220K. Snippy. And Snippy once again. Put that away. Wish I was doing this in a makerspace. A lot more room, a lot more tools, but then again, I probably wouldn't be doing this if I had access to a makerspace. Or it would be a different place. Let's make sure I'm just gonna unplug my, oh, I should tin the soldering iron. It is completely dead. All right, I'm gonna have it warm up so I can tin it again. So I don't have to buy another tip. Because if you don't tin your tip before you put it away, it will wear out and oxidize super quick, and that is nasty and expensive, probably. So resistor here, here. All right, we got our 220 on the breadboard. Let's hook up some wires. Do I have any super long jumper wires? It's pretty long. And this is also very long, perfect. So I'm gonna put these on each side of the resistor, of course, so that I can make that connection. And again, wish I had a third hand because I need to be able to hold these two to the appropriate points while touching, while pressing the buttons on the front. Hey, Chris.
Hi.
How's it going?
I meant to stop by earlier, but I was playing around with some other cool sound stuff that I'm going to show you later.
That's okay. I've been on a roll of in this last hour and 10 minutes, I've gotten two bends. So,
yeah, I've been watching it. It seems awesome.
are you
where
able to
are you
hear the sounds that are coming out of it?
Yeah. Can you
Okay,
give it another go?
fantastic. Yeah. Sorry, just taking a sip of coffee. What kind of sound stuff have you been messing with?
I've been playing around with the p5.js, all of that kind of stuff, which has its own
Nice.
sound.
That's awesome. Yeah, and if we end up doing web development or Glitch or something, that'd be so cool that they can do P5 within their website, right?
Yeah, that'd be super cool. You can make your own sort of like visual audio synthesizer web page.
That's so cool.
Where's that?
You hear that?
Oh yeah.
All right, so this is the loop that I've gotten so far. I mean, okay.
Where's that? Level 2.
See, I need 4 hands to do this.
Where's that? Level 3.
Because like I have to press it and then I have to turn these on. I'm sorry, I can't show you the loop glitch, but you've already seen it, so it's fine.
Yeah, I've been watching.
Cool. I'm about to do this what is it? A voice distortion. No. A pitch control with distortion. So let's see what that sounds like. Yeah. So I also know that you've circuit bent some stuff yourself, right?
A while ago, I was playing around
Yeah.
with it. It's a lot of fun because you sort of open up anything and poke around and see how it changes. The
Mhm.
sounds.
Totally. As long as it doesn't plug into a wall.
Absolutely.
For,
Yeah, that would
for
be
listeners
way
at
too
home, that would be irresponsible. Okay. Like, do you have any advice for like how to clip these two to the circuit board? Like, if I had some clothespins, that would be
Mhm.
really handy because I obviously don't want anything metal because it'll just conduct
Yeah.
whatever I'm trying to connect.
So
Yeah.
you need them permanently, or not really permanently.
No, yeah, right
just
now
a
I need it
test.
temporarily. So like so these will hold while I can press the buttons on the back.
Yeah.
Um,
Do you have alligator clips?
I do, but those will just conduct all the electricity.
I see. Okay.
I could, I could like tape it. Seems
Yeah.
pretty janky.
It's just a test.
Yeah. Or I could loop it. Yeah, I'm gonna loop it and then play around with that. So, boom. So can you tell me a little bit more about the thing you circuit bent? Like, what was it?
Yeah, sure. So I took apart it was kind of like this, I guess, toaster toy. So you like press down a lever on it, sort of like as if you were toasting a piece of bread. And then it says some words. And then I opened it up and added some resistors. I don't remember exactly what I did, but basically just played around with it until it sounded super cool. And then I added a potentiometer, which I see you did here too. So you can kind of like modulate that sound.
Okay, wait, here's the moment of truth. Can you hear that? Here, let me switch it.
A little bit, yeah.
It's pretty quiet. It's like a tick, 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 tick.
Mhm.
So I'm gonna see if the pitch changes when I make these two connections. Oh, it's already a lower pitch.
When you make that connection, it gets really quiet, at least on my end.
It goes down in pitch. Let me see what happens when I increase the resistance. Oh, okay. All right, that's definitely, that's a reliable connection in my book. So that gets soldered.
Level 3.
Cool. So, sorry, you were in the middle of talking. So I assume the toaster was like a kid's toy, right?
Oh yeah, yeah.
Yeah.
Just something I found at a thrift store.
Cool.
Yeah, it's fun to do. I want to do it some more, especially seeing the stream and all the cool circuit bent stuff you've been doing.
Yeah. What kind of bends did you put? You put a pitch, I assume.
I mean, it was a few years ago, so I don't remember exactly what I did.
For sure.
And I definitely don't remember what it sounded like from the beginning. I think it was just some like, talking, and then it became like wild noise.
Yeah. That's exactly what you want.
Yeah. How many different speak-in spells have you messed with?
This is the one and only.
Oh, okay. I'm imagining you have like 50 around your room. That's what I was.
I mean, honestly, the shameful fact is that like I only have 2 or 3 completed circuit bent projects. The rest of them have either like died from overuse or from incorrect handling, or have just like given them to friends as presents. So I don't have that much to show. I just have the dinosaur synth, and then I have this like little like a play fob of plastic keys, where it has these buttons that like make like little doorbell noises.
Nice.
That's really it. So, but once I have this under my belt, then they'll have to take me seriously. I don't know who they are, but
They definitely will, though.
they definitely will, though. Yeah.
Yeah, you're gonna have a lot of fun with this P5 sound library, I think.
And honestly, I'm always looking for more JavaScript experience.
It is,
Um,
you know, digital sound. I know you're all about that analog sound, but
No, but especially like digital or coding digital sound is super interesting because you can program all these different ways of feedback.
Mhm.
And I think digital feedback is just such an interesting idea. And because you're not actually limited to physical outputs and inputs, you can just create as many of them as you want, assuming your software is flexible enough.
Yeah.
So that is a very exciting idea indeed. Yeah, hopefully the kids are half as excited about it as we are.
How are you finishing this thing up here? What are you up to?
The stream?
Oh no, the speak and spell. What are you soldering right now?
I am soldering the pitch thingy that we just discovered. And then once I have that, I'm gonna test what value of potentiometer would be most ideal for it.
Sweet.
Yeah. But yeah, honestly, I haven't soldered in so long. So very much out of practice.
Yeah. Now you have to solder on camera.
Yeah, seriously, but honestly, it's good motivation. I've been meaning to circuit bend this thing for like months.
That's a great soldering iron. I was thinking of buying one a while ago.
It's so good. It's like, if you have a power bank, it can be completely portable too.
Mm-hmm.
Not that I can ever see myself needing a soldering iron in the middle of the field or something like that, as people say.
I thought that was the rechargeable one. I was looking at a rechargeable soldering iron.
Oh no, this you would need like a USB-C compatible battery pack in your back pocket or something.
Got it.
But what was I gonna say? I also have a butane-powered soldering iron, which is pretty dope.
Wild, yeah.
And I saw it at Ace Hardware, and I just bought it on a whim. Of course, I've never used it.
Have you seen the battery-powered Milwaukee soldering irons?
No. Does it use like those giant Milwaukee batteries, or is it like different?
I think it uses smaller Milwaukee batteries.
Nice. That's good. Do you think it would be okay if I took a drill from BitSpace at some point?
Well, now I'm saying this on the record. I think that it should be okay, but it's worth an ask.
I'll confirm.
It uses the tiny Milwaukee batteries. That's a live update here.
I only ask because I'd love to start, once all these bends are done, I want to start drilling through this plastic shell.
Yeah.
And, actually fitting in all this stuff. Let me see. The M12 soldering iron Hero.
Oh yeah.
Hero shot. Wait, is it called the Hero, or is it just a Hero shot? Whatever that means.
I think it's just called the M12 soldering iron. Yeah.
Okay, but this is the Hero shot. That's a very interesting way of titling it. Solder. That looks awesome. It looks very bulky, but I guess that's because there's a giant battery in it.
Whoa. Yes.
Yeah, but I honestly, I cannot recommend this soldering iron enough. Like, especially because, you know, before I graduated college, I was just having to go back, you know, every time I go for break, I'd go home. So I would just be able to bring my soldering iron back and forth, which is, I don't know if a lot of people encounter that problem, but I certainly do.
You never know when you're going to need a soldering iron.
Right. Exactly. Yeah, so I'm just tinning the wires now.
Those helping hands are ridiculously helpful.
Yeah, lifesavers. Have you seen the ones that look like very cute octopi?
No.
And so they like have 8 hands that are all super flexible.
That
Those
sounds
are awesome.
even more useful.
Yeah, and you can like 3D print helping hands too, which is something I've been meaning to do. I have a big folder of things I need to 3D print, and that's on them.
Totally.
I also really want to make a little box, like a little device that'll allow me to that'll help me with circuit bending. Let me show you what I have. You know, it's not worth it. It's what I needed for those banana to mini hook things. It's going to be just like a small box with 2 jacks on it, then and then potentiometers wired in series, so that it's super easy to just clip on, and then you can like vary the resistance just from this little box instead of having to set it up on the breadboard every time.
That sounds really, really nice.
Yeah, I think it'll make my life so much easier. I made a maker case for it, but I did a kerf box, and I didn't realize that the sides of it is all one piece. Have you ever tried to make a kerf box?
From maker case?
Yeah.
Yeah.
So with the rounded corners. So I didn't realize that the entire side of it is all one piece. And the size I had, it was like 4 inches over the maximum amount.
Oh, yeah. The rounded corner boxes aren't necessarily like they're not ready for prime time yet.
Oh, really?
On that website. Yeah, they're super new. It's good to just stick with the standard box.
Yeah, I wanted a cool little handheld device, but
yeah,
that works too. Okay, I'm pretty sure this is the right one. Got this. I keep forgetting that this isn't necessarily in frame, but that's okay. Have you used P5 or processing much before this?
a while ago. I used it back in college, but it's really great looking into it again deeply and seeing like how far it's come. Seems like there's the ability to do pretty much anything in it.
Totally.
You get sounds. You can do like live. Like you can mess with the webcam live. It's a lot of cool stuff you could do.
You can mess with the webcam live, so you can like actually stream on your website within it?
Possibly. Yeah. I mean, it'll take the webcam of whoever visits the page.
Oh,
and you can do like live like mirror stuff.
That's so cool.
Yeah.
Yeah, it really seems like the possibilities are sort of endless there. Okay, those wires are set. Let's hear what this sounds like. So one of them is going into this 220K, which is then going into a 100K. So the range is 220 to 320. We'll put this in the breadboard. I got 4 more minutes left, so you know what? This is a good way to end it. Come on. You know, unless I won't fit into the breadboard.
Oh no.
Okay, that's good enough. All right, moment of truth. Also, do you know if we have knobs at BitSpace?
Just normal knobs.
Just normal 6mm knobs.
I don't know if we do. It's worth a look, but I don't know off the top of my head.
Yeah, that is like, knobs are surprisingly expensive and difficult to come by.
Weird.
Batteries in. Let's see if this turns on.
Word tap. Level 1. Word tap. Level 2.
Okay, that's not really sounding like it's making much of a difference.
Word tap. Level 3.
Oh,
Word tap. Level 1.
come on.
Word tap. Level 2. Word tap. Level 3.
It's pretty similar to my first one. Let me get my final act. Let me get a giant potentiometer and see if that makes a difference. So I'm increasing it by a factor of 10.
There's a lot of trial and error in circuit bending.
Oh yeah, it's all trial and error, but that's what makes it awesome. That's what makes it so accessible.
Definitely.
Word tap. Level 1.
It's not giving me very noticeable results.
Word tap. Level 2.
So what were you?
Level 3. Word tap. Level 1.
Which value are you hoping to mess with the potentiometer?
Pitch.
Pitch. Okay.
Oh my God. I think I accidentally soldered it to the wrong point. Oh, that's so annoying. Well, okay, but you know what? That's fine. I can easily test this.
Couldn't you just chop it and solder it to the point you're looking for?
Yeah, totally.
Cool.
Word tap. Level 1.
Hmm.
Word tap. Word tap. Level 3. Word tap. Level 1. Word tap. Level 2. Word tap. Level 3.
Okay, still not giving me a very desirable or like a very noticeable pitch difference, which is weird. But you know what? That's the experience. That's the journey.
Word tap. Level 1. Word tap. Level 2. 1.
Okay. Well, you know what? I'm still happy with my progress. I'm gonna keep working on this over my lunch break.
Nice. Yeah.
But
I mean, yeah.
No, sorry. What were we gonna say?
I was just going to say you can always mess with circuit bend stuff. You can always change it around and make it even cooler.
Absolutely. Oh yeah. I'm gonna add so much stuff to this thing. There's so many possibilities with these crazy chips. Okay. Well,
Sweet.
thus concludes this live stream. I believe we had 2 viewers, one of which is me, and the other of which is you. So
Perfect.
it was nice talking to you. Thank you for being my audience.
Thank you for showing me your cool circuit bend stuff. I might try it out myself if I can get my hands on a Speak and Spell.
Yeah. If thrift stores are open, I feel like that'd be a good way to spend my time. Then again, social distance. Stay in your home, people.
True.
Okay. All right. I'll talk to you later. End of stream. Bye.
Bye.
And cancel the stream.